The length is equal to x plus x, which is equal to what? 2x. We are asked to look for the length of the chord, but we know that the length is 2 times x, where this is x and this is x. Consider this triangle that we have here. Let's label it. You can call this O for center. I can call here A. I can call there B. From triangle OAB. From triangle OAB, I can say 5 square. Why 5 square? This is my hypotenuse because it's facing the right angle. It's equal to the sum of the squares of the adjacent sides. This is an adjacent side. That's the second adjacent side. So I have here 3 square plus x square. Now this gives me 25. This gives me 9. And that's my x square. I have 25 minus 9. If I transfer 9 this way, and that gives me 16. This is x squared. Of course, from here we can solve that our x is what? Root of 16, which is 4 centimeters. If x is 4 centimeters, that is not the answer yet. We're asked to find the length of the chord, but we know that the length of the chord is twice this. That's 2x. Therefore, the length of the chord L is equal to 2x, which is 2 times 4, and that gives us 8 centimeters. Take a closer look on this. We advance straight and take another example. Now we look at a second example that concerns the idea of chord in a circle. Here we are told that if a chord of length 16 centimeters, in this case we have been given the length. Let's quickly represent that. And the chord, I can draw a chord this way anyhow I like. I can draw my chord. That's a chord. We are told that the length from here to here is what? Is 16 centimeters. So I say, okay, this is 16. Thank you. That's my center. A chord of length 16 centimeters is drawn 6 centimeters from the center. Oh, the chord, the distance of the chord from the center is 6 centimeters. Is drawn 6 centimeters from the center of a circle. So from here, this way is 6 centimeters. Remember, this line being perpendicular to what? To the chord, divides the chord into 2 equal halves. The length of the chord is 16. Therefore, if I divide by 2, when I was in nursery 2, 16 divided by 8, divided by 2 should give me 8. Yes, will also be what? 8. I'm very sure things have not changed. Calculate the radius of the circle. What's the radius? The distance from the center to any point on the circumference. So I can pick from here to there, or I can pick from here that way. It doesn't matter which, so I go there. Let me call this R. We are looking for the radius. Remember, this is also 90 degrees. I have a right angle triangle, and I can see the hypotenuse happens to be the radius. It's facing the right angle. I say, okay. Again, applying Pythagoras. Applying Pythagoras. We say R squared is equal to what? 8 squared plus 6 squared. The adjacent sides. And that gives me 64 plus 36. And that is what? 100. So R squared is what? 100. My R is therefore root of 100. And that gives us 10 centimeters. That's quite splendid. We'll take 2 more examples and then we'll advance to SOHCAHTOA. Just before we consider using trig ratios to solve right angle triangle, talking about SOHCAHTOA, we'll take 3 more examples on the application of Pythagoras theorem in solving right angle triangle. Let's look at this. Our first one here says the sides of a rhombus are 17 centimeters long. If one diagonal is 16 centimeters long, what is the length of the other diagonal? First and foremost, we should ask ourselves, what's a rhombus? A rhombus is a four-sided shape that has all sides equal. And again, the diagonals of a rhombus bisect each other at 90 degrees. Very important point. I pick my rhombus. All sides equal, just like a square. As a matter of fact, a square is from the family of rhombus. All sides equal, and the diagonals bisect each other at 90 degrees. We are told that the sides of a rhombus are 17 centimeters long. So this is 17, this is 17, this is 17, this is 17. And that the length of one diagonal is 16 centimeters long. If this is 16, that's the diagonal, we have to calculate the length of this other diagonal. Remember I said that the diagonals bisect each other. Bisecting means what? Dividing each other into two equal halves. If I call this x, I call this x. If I call here y, I call here y. Because this length is equal to this length. Likewise, this length equal to this other length. But we have been told that one of them is 16 centimeters. So if this is 16, it means instead of x, I should have what? 8 there, and have what? 8 here. We are asked to find the length of the second diagonal. Let's call that length L. From what we have here, the length of this diagonal will be what? Y plus y. Which is what? 2y. But how do we calculate our y? Let's look at y from this direction. We are told that what? The diagonals bisect each other at 90 degrees. Wonderful. That gives us what? A right angle triangle here. You can see a triangle and one of the angles is 90 degrees. So I can apply my Pythagoras here. I'm looking for y. I have these other two sides. Again, this is the hypotenuse. Why? Because it is facing the right angle. So I can apply Pythagoras to take care of this triangle. And I say the hypotenuse square is equal to what? The sum of the squares of the adjacent sides. 8 and y. So I have 8 squared, y squared. 17 squared is what? 289. And this is 64 plus y squared. Transfer 64 this way, we have 289 minus 64 gives me y squared. 289 minus 64, that is 225, which is y squared. And therefore I can say my y squared is equal to 225, and my y is therefore what? Root 225. Hence, y is what? 15. If y is 15, what is L? The length of the diagonal. That is what the question demands. What is the length of the diagonal? This is 15. 15 plus 15 will give us 30. As indicated here, that the length of our diagonal from the diagram is y plus y, which gives us 2y. Therefore, the length of my diagonal is 15 times 2, which is 30 centimeters. Wonderful application of Pythagoras theorem. Next, we look at another example. Here in an equilateral triangle. Calculate the height of an equilateral triangle with sides each 10 centimeters long. Equilateral triangle is what? A triangle with all sides equal. All sides equal. And we are told that the sides are what? 10 centimeters each. 10 centimeters each. I'm looking for the height. The height of a triangle should be what? Should be the perpendicular distance from a vertex to one other side. So if I go this way, that's the height. This length. Now because this is equilateral, the height here, this length, bisects this into two parts. So instead of writing 10 here, I call this 5 and I call this 5. And immediately I see a right angle triangle. I can call this PQR. From triangle PQR, I can find the height. Let's call this H. Again, this is our hypotenuse. Why? Because it is facing the right angle. So we say therefore, 10 squared, our hypotenuse, is equal to what? The sum of the squares of the adjacent sides. Where are they? H and 5. H squared, 5 squared. I have here 100 is equal to H squared plus 25. Transfer this way, I have 100 minus 25 is equal to what? H squared. This gives me 75. H squared. So H squared is what? 75. H is square root of 75. Of course, I can put this in short form. This is going to be root 25 times 3. And that results in 5 root 3. You can also use your calculator to get the exact figure. The question was calculate the height of an equilateral triangle with sides 10 centimeters each. How did we get this out? Simply drew this line down to represent the height, which divided what space into two parts. So instead of 10 here, we have 5, 5. And then we obtained a right angle triangle there and applied Pythagoras. Finally, that's our last question, application of Pythagoras theorem. A man cycles 9 kilometers due south. I believe we all know what is north, west, and east. That's the north. That direction, east, this way, west, and this way, south. So if a man goes due south, it means if he leaves this position, he's actually traveling downward. 9 kilometers due south. So let's say this is our 9 kilometers. Arrives this point. On arriving at this point, he decides to change direction and travels 8 kilometers due east. That way, from here it takes off and moves there, 8 kilometers. And the question says, how far is he from his starting point? This is his final position. This is the starting point. So we are looking for this distance. Again, since this is due south, due east, we are privileged to have what? 90 degrees there. And which means we have a right angle triangle. So Pythagoras can play again. Let's call this distance we are looking for x. So x represents the distance of what? Final position from his starting point. Applying Pythagoras here. Applying Pythagoras. We have, where's the hypotenuse? Is x. Why is it the hypotenuse? It is facing our right angle. So we have here x squared is what? 9 squared plus 8 squared. 9 squared is 81. 8 squared is 64. And we add these two, it gives us 5, 14, 145. And then x will be what? The square root of 145, which is equal to 12.04 kilometers. So that's it on the application of Pythagoras theorem in solving right angle triangle. Next, we are looking at using trig ratios to solve right angle triangles. The popular concept is called SOHCAHTOA. SOHCAHTOA. What's the reason for this? If you look at our Pythagoras theorem, let's bring our right angle triangle back into the picture. Let's call this A, B, C. So this will be side B, side C, side A. If I develop the Pythagoras theorem here, I will have B squared equal to A squared plus C squared. We have three variables. In this case, we must be given at least two of the sides for us to determine the third side. What about a situation like this? Still the right angle triangle. And we are just given this side. Let's say this is 10 centimeters. And we are asked to find, let's say, x. And that's all. We can't apply Pythagoras theorem here. Why? We do not know this side. And possibly, we don't know this side. We are not even given no information about this side. And we have only this. Pythagoras cannot play at this point in time. For questions like this to be solved, one of these two angles will be given. If we are given this angle here, theta, then we can apply SOHCAHTOA. Let us interpret the meaning of SOHCAHTOA. Remember, we are looking at how to use the trig ratios to solve right angle triangles. We call this A, B, C. This time around, we have an angle given to us. This is B, this is A, and this is this is C, and this is side A. We have SOHCAHTOA. Your S, of course, stands for sine, the C stands for cosine, and the T stands for tangent. Sine represents what? That we say sine theta, the sine of an angle theta, by so implies opposite O all over H. Which in this diagram we have here, what do we mean by opposite? And what do we mean by hypotenuse? Of course, we already know the hypotenuse as what? As B. So which side is going to be the opposite? All along, I have been saying that this side, the side facing the right angle, is our what? Hypotenuse. And I've always referred to these two sides as the adjacent sides. But now, the moment of truth has come. One of these two sides will become the opposite side, and the other one will retain what? Being called the adjacent side. But which of the two will become the opposite? We look at the angle given to us. If we are given this angle, or this is our considered angle, the side facing the considered angle is addressed as the opposite side. And of course, the remaining side remains the adjacent side. Please take note of this. I said the considered angle. If the considered angle happens to be this other angle, then our A will be the opposite side and C will be the adjacent side. So right now, our C is the opposite side and then A retains what? Being the adjacent side. So sin theta in this case will be what? Opposite, which is C, all over what? Hypotenuse, B. And if I bring this out, we have sin theta being equals to C over D. Cos represents cos theta, adjacent over hypotenuse. Adjacent over hypotenuse. The adjacent is A, the hypotenuse is B. So we have A all over B. And tan theta is equal to what? Opposite O all over adjacent. A opposite all over adjacent. And what is the opposite in this case? C. And our adjacent is A. So that is how we apply sine, cos, and tan. But mind you, you cannot apply the three at the same time. What do? You will have to decide which of these three to use. How do we decide which of them to use? Let's look at the example we were just trying to treat a while ago. I'll repeat this on this part of the board. In place of my theta, I will put 30 degrees. And I'll call this 10. And this is x. The question says, find the value of x. This is a right angle. How do I apply SOHCAHTOA in solving this problem? First and foremost, when you see a right angle triangle, your mind goes straight to what? Goes straight to Pythagoras theorem. And I say, oh, Pythagoras, x squared hypotenuse must be equal to what? 10 squared plus, sorry, I did not know this. Then I dropped the idea of using Pythagoras. And then I look at what? SOHCAHTOA. How can you help me? Okay, I've been asked to look for x. If I'm looking for x, what is the x? It is the hypotenuse, okay? Now that I don't know x, do I have any side that is known? Yes, I know this side. Oh, what side is this? Is it the opposite or the adjacent? Oh, it 10 happens to be the opposite side. Okay, in that case, I'm combining hypotenuse and opposite. Looking at SOHCAHTOA, which of these should I apply in solving this problem? Sine combines opposite and hypotenuse. Cosine combines adjacent and hypotenuse. And tan combines opposite and what? Adjacent. Of course, of these three, sine wins. So I'm going to apply sine in solving this problem because sine combines opposite and hypotenuse. And here I'm looking for the hypotenuse. I've been provided with what? The opposite. I say, okay, sine theta is opposite over what? Hypotenuse. What's my theta? The angle provided, 30 degrees. Oh, sine 30 is equal to what? Our opposite is what? 10 over hypotenuse. Oh, that's the unknown, x. Alright. What's sine 30? I checked my 4-figure table and I found that this is 0.5000. And this is equals to 10 divided by x. Then I cross multiply. X times this gives me 0.5x. And 10 times 1 gives me 10. So my x is what? My x will be 10 divided by 0.5. And we have this as what? As 20. So, okay, so that means our x is 20 centimeters. So that's it. Our first example, in considering what? The use of trig ratios in solving right angle triangle. More examples to come. We look at more fundamental application of the concept of SOHCAHTOA. On the board here, we have 3 problems. Let's start with the one on the extreme left. The diagram here represents a right angle triangle. As you can see, there are 2 sides that are not known, and we are told to find x and y. We have been provided with an angle. Now, looking at this, let's assume I want to apply Pythagoras theorem, which is always our first thought. My mind will go straight to 8 squared, being the hypotenuse, y squared plus x squared. I can't apply this because there are two unknowns. So I forgot about the idea of what? Of using Pythagoras. And I begin to look at what? Using SOHCAHTOA. I said, okay, let me look for my x first. If I'm going to look for x first, obviously I'm going to forget about y. So I'll be looking at x and looking at the given one, 8. I label my triangle first. This is my considered angle. Already we know that 8 is the hypotenuse. Why? Because it is facing the right angle. So that's my hypotenuse. It is given. Right? 8 has been given as the hypotenuse. And I'm looking for x. What is x? Is it the opposite or is it the adjacent? And look at this. The opposite will be y because it's facing our considered angle. In that case, my x is the adjacent. And I say, okay, I'm combining h and a. SOHCAHTOA. Who am I going to use among you guys? SOHCAHTOA. Yeah? Oh no. Cosine is what? Adjacent over hypotenuse. So I'm going to apply cosine in this case. So I'll say that cos theta. Let's roll this a little bit. That cos theta is equal to what? Adjacent over hypotenuse. In this case, what is our theta? Our theta is 32 degrees. And adjacent in this case is what? X. And our hypotenuse is 8. So it's okay. X times 1 cross multiplying gives us x. And 8 times cos 32 is 8 times cos of 32. I will check our four-figure table. X equal to 8 times 0.8480. And if we multiply this, we have 8 by 8 is 64, 8 by 4, 32, and 6 is 38, 3, 64, 67. So we have 6.784 centimeters as the value of x. Now that we know x, and we also have this, of course we can now apply Pythagoras if you want to. But we've already applied Pythagoras very well. Let us still continue learning how to use trig ratio. So I pretend as though I don't know x. I look at y. I look at 8. I say, oh, y is opposite. The only given side is 8 and it is hypotenuse. What trig ratio do I use for this? Remember SOHCAHTOA, opposite hypotenuse. Here we go. So in this case, I apply sine because that combines what? Opposite and hypotenuse. So I say, okay, sine theta is opposite over what? Hypotenuse. Our theta is 32. My opposite is y. And then my hypotenuse is what? Is 8. Sine 32 is 0.5299 equals y all over 8. Cross multiply here. Y times 1 gives me y. And 8 times this gives me 8 times 0.5299. And if I multiply 8 by 9, we have, I think that should be 72. Right? And then we take what? 72, that's 9. This is 16, 23, 40, 42. So we have there approximately 4.24 centimeters. So that's it for the first one. We have to look for what? X and Y. I'm moving to the second question there. This time we should start building up speed. I believe we begin to understand this better and faster. Here we have to look for P and Q. Quickly, what do we have? That's the right angle triangle. Sorry, it was not in place. I'm looking for PQ. Well, let's start with P. Let's Q, wait. I'm looking for P. P is the hypotenuse. Yes. I have 10. What's 10 to this angle? Opposite. Again, what do we have? Sine, obviously. Hypotenuse and opposite, looking at your SOHCAHTOA. That's sine. So, okay, sine theta. We know is what? Opposite over hypotenuse. What are we looking at? Sine 60 in this case. Opposite is 10. And this is what? P. Hypotenuse is P. What's sine 60? Sine 60 is 0.8660. 10 divided by P. We cross multiply this times this gives us 0.866 P equals to 10 times 1, 10. My P is therefore 10 divided by 0.866, and that gives us 11.55. So that's it for P. I look for Q, and I can quickly say here, to find my Q, why should I bother myself again with SOHCAHTOA, since I can also apply Pythagoras? Since I now know P and I have 10, let me go straight and use Pythagoras. And that's using Pythagoras. Pythagoras combines 3. 1, 2, 3. But 2 must be known. Now I have 10, and we also know P to be what? 11.55. So we say, Pythagoras states that what? The square of the hypotenuse, P squared, is equal to 10 squared plus Q squared. What's P squared? P is 11.55 all squared, equal to 10 squared plus Q squared. That gives us